pattern or the parametrization we can say in case in Java. So we will take the example of the cars and divide the cars into the multiple different. The cars can have different type. Like say, car can be a hatchback, and car can be the sedan or the SUV. And you have a list of cars, so you have multiple cars. Right, you're a very rich person and you have, let's say, 25 cars. And any day you decide on your mood, based on mood you select the cars, and those cars you take the office whenever you try to go to somewhere. So you have in your garage you have, let's say, a number of the cars, that is in our case we taken the 25. Now you want to write the logic of automate that particular logic of selecting different types of cars. First you want to select car that is the SUV types. It will write our scenario first. In first case you will write select the car that is the SUV type. Later you want to change your logic. You want to search of, for example, let's say sedan. You want to search the hatchback. Third, you want to search it based on some other properties. Let's say you want to search the lengthy cars. And fourth, we will come up with the more scenarios here. Let's come to the coding part. So for example, you have given these cars. In each car has a name, each car has a length, or each car has a type. Right, and that is the get inventory method which returns you all the cars. So first you want to filters. First approach is filter only sedan that you want. So you will write a logic public static at list of cars that you will return out of all cars. Filter sedan cars. You will get list of car. You will get the cars. And how that filtration logic will be? You will have list of car as a result. Filter cars, new, and you return this filtered. Now the logic you have to write how you will populate the cars into particular filter cars. So you will iterate over each car in the cars that you're given to you. You will check if the condition is being satisfied. So our condition is to check for the sedan. So here we will write the car dot get this type if it is equal to the car type dot sedan. So once it logic has been satisfied, in that case, what you're going to do, you will add it that those cars to the filter cars dot add cars to yeah car you have added. Let's try our logic here. So we'll go to our main methods. We'll get list of sorry car. Here is the filtered cars is equal to you'll get a filtered sedan cars. You'll pass all the cars. And now we have a utility method that is a print car. Here you can go sedan cars, or the second method is good. Let's run our code. The code is currently building. It probably takes some time for the first time of the building. You will find all the cars that are sedan, that is the Honda City, as well as Maruti Suzuki Ciaz, Audi A. But what if after some time you change your mood and you want to filter the SUV cars? What you are going to do? Oh, you said that's the simple things. You go ahead, you copy these methods, you do here, you instead of sedan, you write SUVs, and you're done. And here you'll change the method of SUVs, and then you will call that particular methods and return. But have you noticed you are doing exactly the same thing? It's completely duplication of your methods. You are actually violating the dry principle here. So that's not the right approach. So you said that, oh, they are passing, you can pass it using the values. Right. So you are going to update your methods, and the first approach where you have used it like write a method. So you said that I will update this method and I will pass type as a value the parameter. So what you are going to do, you copy this particular method instead of filter cars by type, and you take another argument here, that is the car type. You take the type, instead of checking it with the sedan, you check it here with the type. Yeah, I'm just keeping the previous method, but now it is not required. You can always pass the type here and can get the whatever the car type. So this is the thing we are intended to do here. Car filter cars. Okay. So I'm using the same variable that we have used the filter cars and assigning it using our new method filter cars by type. Here we pass the R. And if you need the car type of SUVs, you have what you have to do. You take the car type and you have SUVs. In cars. Yeah. Again, we are running this. Oh, we get the car of type SUVs. Good. This method is more flexible than the previous method, but still, for what if you have to pass check for the another type? For example, you want to go in the car which is lengthier than 4500 meter, right? So you are going to write another method, right? You are going to write another methods, and here instead of type, you will check it's by length. Then you compare. Let's do write a method. So instead of type, we are going by the length length int length, and if car dot get length is greater than length. But if you want to check lesser, again you have to recopy these methods and do some kind of the stuffs. But value parameter on length property filter car by length, instead of type now we will pass 45 and figures. So here see we will see the lengthy cars as the Honda City, your OD89, your XUV 700, blah blah blah. These are the cars. Now you see again you are repeating a lot of logics between different properties when you have to filters. So there is a concept of you can define the predicates. So in case of the predicate, you see the car predicate and you have a validator, or let's say some test methods, and then you can have its implementations. Right? And then we have created an SUV car predicate, and there we can define the rules of filtering the cars. Now let's go. What is the advantage of using this? So now our filter methods, you don't have to write the methods like this. Instead of, you can change your filter method like filters. You can do the car, or you can have the car predicate, and here instead of these conditions, we will have the predicate dot test and pass the. So what is this? Now your filter method is quite abstract, and it says that you pass me the code. You are passing the behavior, that is the behavior parameterization. You're passing the strategy, that is the strategy design pattern. Right? You're passing the behavior, and based on that behavior, you are doing the something, and that behavior could be anything. So now what you have to do, you are doing the behavior parameterization based on the class implementation. Implementation. Hmm. So again, we are doing the filter cast, but this time you are using the filter cast methods, and we are again filtering the SUV cars here. But this time you have to pass all the cars and new SUV car predicate. Why there is an error? Okay, I think the method name is here the filters. Hmm. So you can go give the car, you can give the predicate, and it returns the filter card. Again, we will can print the SUV cars. V cars with predicate. Again, run the method. So this time you will get all the SUV cars, but this time you are doing the with the predicate. Your flexibility keeps on increasing. I think if you are noticing properly. So this time you will find the Tata Safari and the Mahindra XUV S700 as the cars which are SUV cars. But still, you said that this is more complex because you define the car predicate, and for every type of filtrations you have created a new class. Oh, that's the problem that you don't want. So there is a concept of anonymous class. Anonymous class. Right. So you can give the behavior which is based on the anonymous class. So this time we will again calling our filter method. We are using the same, and we want to search for the our hatchback cars. So hatchback cars with predicate and anonymous function. Okay. You are instead of predicate, what you are going to do here, you are going to give the its implementation directly. New car predicate. Here you will give directly give the conditions. New car dot get type and is equal to car type dot hatch. And you are now searching for the hatchback. Okay. This time we find the hatchback cars, and we are using the anonymous function, but you have again noticed one major problem here. So you have to pass actually this behavior only, you want to behavior this only, but previous to the Java 9 you all have always need to pass this as the whole. You have to wrap it in a particular class, and only the class object you can pass out, and so you cannot pass the behavior. But later on, whenever the lambda expression comes, you can directly pass the behavior. So that's what we are doing here. So we know the our predicate. To use the lambda expression, your predicate should have only a single function, and let's see how to use it. Again, we have to, let's say, filter the cars of type sedan. So I'm copy pasting the logic where we have actually done. Let's say we copy this method, filter using the lambda expression. You can do it here. Filter cast by type, instead you will using your filter, that is an abstract method, but now you have to pass the behavior. We see the behavior can be passed using the implementation, using a class, using anonymous functions, and now using the lambda expression. Lambda expression, you will pass the car, and this car has an implementation. What is the implementation? Is car dot get type is equal to car type dot sedan. and and now you can see you can pass lambda. So now you can see that we have filtered out the sedan car. The main concept is we have learned how we actually evaluated our functions. First, we have the same implementation, single implementation for sedan car, but then we have different requirements of in the same type. Then we use the value parameterizations. Then we have noticed that the we probably need to filter on the other methods as well. Then again causing the duplicate. So then we use the concept of predicate, and the caller itself can pass the behavior. But to pass the behavior, first we use the class implementations, but it requires the unnecessary classes in our project. So to reduce that, we use the anonymous functions, but we actually intended to pass the behavior, but we have to wrap that always in certain methods. So for that, we use the lambda expressions. I hope you like the video. Thank you.